Have you ever looked at someone who seems to thrive on exhaustion? You know the type. The person who works a demanding 10-hour shift, goes to the gym to lift heavy weights until their muscles tear, cooks a complex meal from scratch, reads a dense nonfiction book, and wakes up the next morning eager to do it all over again. When we observe these people, we tell ourselves a comforting lie. We say they are just built differently. We assume they have some genetic mutation, an overactive thyroid, or a biological advantage that makes them immune to the friction of daily life. We tell ourselves this lie because the alternative is deeply uncomfortable. The alternative is that they are exactly like you. We live in a culture obsessed with ease. We have engineered a society entirely dedicated to the eradication of friction. Food arrives at our door with a tap. Entertainment is algorithmically piped into our retinas in 15-second increments. We don't even have to remember our own schedules anymore. Our devices chime to tell us where to look next. Yet, as life has exponentially decreased in difficulty, our baseline levels of exhaustion, burnout, and apathy have skyrocketed. Giving up has never been easier, and we are doing it faster than ever before. But what if the very things we built to make life easier are exactly what is destroying our capacity to endure? What if the brain wasn't designed to avoid pain, but was actually desperately waiting for you to use it? To understand the modern crisis of motivation, we have to look away from self-help gurus and productivity hacks, and look directly at an obscure, groundbreaking animal experiment that uncovered a biological cheat code, a phenomenon known as learned industriousness. In the realm of psychology, almost everyone has heard of learned helplessness. In the 1960s, researchers discovered that if you subjected animals to negative conditions they couldn't control, they would eventually just lay down and stop trying to escape, even when the doors were thrown wide open. Their brains essentially learned that effort was useless. It was a profound discovery that explained human depression and trauma. But for decades, psychology focused solely on this dark side of the coin. It focused on how the mind breaks. It wasn't until 1992 that a brilliant psychologist named Dr. Robert Eisenberger asked the inverse question: if helplessness can be learned, can grit be learned too? Can we train a brain to not just tolerate hardship, but to fundamentally crave it? Eisenberger didn't want to just motivate subjects. He wanted to alter their neurochemistry. He wanted to see if the sensation of intense effort could be mapped to the brain's reward centers. To test this, he set up a highly controlled experiment using rats in specialized enclosures, classic Skinner boxes, but with a twist. He divided the rats into two distinct groups. Group A was the low-effort group. They were placed in an enclosure with a lever. Whenever they pressed the lever, a food pellet dropped. The lever was incredibly light. It required only a tiny nudge, a mere 2 grams of force. Life was easy. They felt hungry, they nudged the lever. They were instantly gratified. Group B was the high-effort group. They were placed in an identical enclosure, but their lever was rigged. To get a single food pellet, these rats had to push down with massive, agonizing force, and not just once. Eisenberger steadily increased the resistance until the rats were straining with all their physical might, pulling, pushing, and failing repeatedly before the mechanism finally clicked and the food dropped. For weeks, Group A lived in a frictionless utopia, while Group B lived in a relentless gymnasium of struggle. If you understand basic conditioning, the first part of this experiment is entirely predictable. Both groups learned to get food. Group B got stronger and learned to push a heavy lever. But Eisenberger wasn't interested in levers. He was interested in the psychology of perseverance. What happens when you take these two groups of animals, one accustomed to easy rewards, the other accustomed to brutal friction, and you introduce them to a completely new, unrelated challenge? A challenge that has absolutely nothing to do with levers or physical strength? Eisenberger took both groups out of their boxes and put them into a brand new environment, a behavioral maze. In this new test, there were no levers to push. Instead, the rats had to navigate a complex puzzle to find an exit. It required patience, cognitive mapping, and the willingness to explore dead ends without getting frustrated. The results were not just statistically significant, they were a biological revelation. Group A, the rats who had lived the easy life, the ones whose previous environment provided immediate, frictionless rewards, gave up almost immediately. At the first sign of a dead end, they exhibited massive spikes in stress, abandoned the puzzle, and sat in the corner. They had learned that if a reward wasn't instant, it wasn't worth the effort. But Group B, The rats who had been forced to strain against the heavy lever for weeks, they transformed into relentless problem solvers. They didn't just try harder, they refused to quit. When they hit a dead end, they immediately pivoted. They explored every corridor, retraced their steps, and attacked the puzzle with a calm, methodical intensity. They persisted far longer and succeeded far more often than the low-effort group. Let's be very clear about what happened here. The heavy lever did not teach them how to solve a maze. The heavy lever taught their brains something much deeper. By forcing them to endure extreme friction to achieve a reward, Eisenberger had successfully rewired their neurochemistry. The sensation of effort, the physical strain, the frustration, the fatigue, was no longer a signal telling their brain to stop. The friction itself had become the trigger for dopamine. Their brains had learned that the feeling of hard work was the immediate precursor to survival. They had achieved learned industriousness. To understand why this is so revolutionary, we need to look under the hood of the mammalian brain specifically, a region called the anterior cingulate cortex and its relationship with the basal ganglia. When you encounter a difficult task, say, staring at a blank document you need to write, or looking at a cold shower you need to step into, your brain runs a lightning-fast cost-benefit analysis. It calculates the metabolic cost, the energy required versus the anticipated reward. For the average person, the friction is the penalty. The brain registers the effort required and floods the body with signals of discomfort, urging you back to safety. It says, "This takes too much energy. Open your phone instead. Scroll, it's cheap, it's easy, and it provides a dopamine spike right now." But learned industriousness fundamentally hacks this cost-benefit algorithm. When you consistently force yourself to perform high-effort tasks and eventually receive the delayed reward, the brain starts to merge the two events. The dopaminergic pathways begin to fire during the effort, not just after it. The discomfort itself becomes a highly conditioned secondary reinforcer. The rats in Group B didn't endure the maze because they were biologically superior. They endured the maze because their brains had been trained to interpret the sensation of trying really hard as a deeply rewarding state of being. They didn't love the maze, they loved the effort. This brings us back to you, and me, and the society we have constructed. If Eisenberger's experiment proves that the brain's baseline for effort is highly malleable, it also acts as a terrifying mirror reflecting our modern environment. Look at the world around you. We have spent the last 2 decades systematically eliminating heavy levers from our daily existence. You no longer have to navigate the friction of getting lost. GPS does it for you. You no longer have to endure the friction of boredom. Boundless digital content is permanently in your pocket. You no longer have to suffer the friction of cooking. An app summons a hot meal in 20 minutes. We are living in an architectural masterpiece of convenience. We are Group A. We are living in the frictionless box, pressing the 2-gram lever, receiving identical, low-quality food pellets of digital dopamine day after day. And the psychological consequences are catastrophic. Because our brains have adapted to a baseline of zero friction, the moment we step outside of our digital utopia and encounter a real-world maze, a difficult college major, a rocky relationship, a demanding creative project, our cost-benefit algorithm short-circuits. We hit the first dead end, our stress levels spike, and we sit in the corner. We label ourselves as burnt out, depressed, or losing motivation, but often we aren't broken. We are just perfectly adapted to an environment that requires absolutely nothing of us. We have accidentally programmed ourselves with learned helplessness, not through trauma, but through sheer, unchecked convenience. So, how do we escape the frictionless box? How do we build learned industriousness in a world designed to make us soft? The answer is both incredibly simple and incredibly difficult. You have to start installing heavy levers in your own life voluntarily. You have to manufacture your own friction. This is the psychological mechanism behind the people who run ultramarathons, or take ice baths, or dedicate years to mastering complex instruments. They are intuitively biohacking their own reward pathways. To build learned industriousness, you cannot just try to be more motivated. Motivation is an emotion, and emotions are fleeting. You need conditioning. You start small. You pick an uncomfortable, high-effort task that has a clear, definitive endpoint. It could be lifting weights. It could be refusing to look at your phone for the first 2 hours of the day. It could be learning a coding language for 30 minutes every night when you'd rather be watching Netflix. The specific action doesn't matter. What matters is the friction. When you hit the wall, when your brain screams at you that the lever is too heavy, that the maze is too complex, and that you should just give up and seek comfort, you have to push through until the task is complete. Every single time you do this, you are not just completing a chore, you are laying down a new layer of myelin in your neurocircuitry. You are teaching your basal ganglia that the sensation of discomfort is a precursor to triumph. If you do this consistently, a profound shift begins to take place. The things that used to exhaust you, the deep work, the difficult conversations, the physical exertion, slowly stop feeling like a punishment. They become the baseline. You begin to look at the easy path not as a relief, but as a trap. The people you admire, the ones who seem to possess an infinite reservoir of willpower, do not have a superpower. They do not have a magical gene that makes work easy. They simply have brains conditioned by resistance. They have spent enough time in the high-effort box that they no longer fear the weight of the lever. They have trained their minds to crave the friction because they know that on the other side of the resistance lies the reward. We cannot control the fact that the modern world is designed to make us fragile, but we can choose whether or not we press the easy lever. The next time you are faced with a difficult task, and you feel that familiar urge to quit, to distract yourself, to take the path of least resistance, pause. Recognize the moment for what it is. It is not an obstacle. It is an opportunity to rewire the machine. Embrace the heavy lever.